Yeah, hi everyone. Thank you. I'm going to go with English, but hope you'll bear with me. Yeah, it's the end of the day. I know, just 30 minutes and we'll be all free, but in the end of the day, it's always about backups. Now, I'm going to go to make sure we're on the same page and we understand what we're all talking about here. It's about mostly backups as part of the disaster recovery. So we're going to talk about the disaster recovery and the most significant threat that is ransomware nowadays. How backups can help recover and what kind of backups those should be, key aspects of disaster recovery overall, and some other hopefully useful tips for you. So what is disaster recovery? Now, disaster recovery is actually a part of a global business continuity strategy, right, which aims at continuing business services running in case of a disaster or bringing them up as soon as possible with your predefined RTO and RPO levels, but we'll get to that. Now, disaster recovery focuses mainly on the IT infrastructure and technological systems that stay behind your workloads, and of course the main aspect, the actual workloads that power the organizations or businesses. Now, why disaster recovery is needed? Well, apparently there are a lot of disaster types: natural disasters, human errors, floods, fires, different types, but the most significant one that comes nowadays is definitely ransomware. Right, so just several numbers to make sure we all understand the importance. It's the usual case when we have to pay the ransom, starts from $1 million and up to $10 million average. And that's, of course, the data only from the reported ransomware attacks. Probably it's much more higher. The estimates, I'm not going into the deep history starting from main ransomware attacks from 2008 to 2010. Predictions are this will be around $250 billion by 2031. And the reason why these costs and these numbers are so high is because it's even more costly to tolerate the downtime of your workloads and applications, unless you, of course, have the ability to recover data without paying the ransom. Now, so what actually makes the proper DR? Now, there are multiple aspects. Of course, the first one is the DR team. Now, in the ideal world, you would want to have a separate, dedicated, constant, your staff DR team. That would include the technicians and researchers that would allow to constantly stay on the most recent DR planning and technologies. In reality, of course, it's a single-man IT department that does all the job, right? A single sysadmin who supports the infrastructure and is, of course, responsible for the disaster recovery aspect and for the backups. Now, in that case, which is usually, very often the case, it's ultimately important to have the C-level of the company being allied on what is the importance of your IT infrastructure. Without understanding that, most likely the budget will be very limited and you'll end up with the unreliable disaster recovery plan. Now, the second most important thing is to properly identify the assets. Now, disaster recovery might seem like a huge deal or requiring a huge budget for that, unless you perform a proper, let's say, evaluation of your assets. Now, this does not necessarily be all of the workloads. For example, in some cases, the corporate internal file server that takes 20 TB might be not that important as the database or the website. So the better you do the job for identifying critical assets, the more you can save on the budget for disaster recovery solution and later pick up proper disaster recovery methods. Now, of course, we need to assess the risks. Misclick. The risks are different. Again, we're focusing on ransomware here because probably you all understand that depending on the, for example, geographical location, if we're not living in Florida, For example, the hurricanes or tornadoes won't matter that much. Again, we need to understand what risks should we be protected against. This means basically if we need a separate disaster recovery site in a separate building or city or state or province or not. Again, this goes about the optimization of the DR methods and budgets. Next, we need to understand the RTO and RPO. Basically, how fast we want to restore. Again, this might be hours, that can be tolerable, or minutes. And of course, the amount of data we can lose, because when we're talking about disaster recovery, usually we are talking about the asynchronous replication or active-passive replication. Now, so that's constantly about some data loss. The question is how much we will lose in this case. And again, based on this, we pick the DR methods. Now, about the DR methods, there is a great variety of those. Today we are focusing exactly on backups as the disaster recovery method. And of course, it's all good, the disaster recovery plan, the methods we pick, and the backups as long as we can restore. Now, apparently, we cannot be sure of that until we do testing on the POC stages of deployment of any kind of solution, and of course, post-deployment constant testing. And very important thing is to conduct proper training for the staff or personnel that is responsible for the disaster recovery implementation. Meaning, in case that ransomware hits or anything other happens, there should be clear protocol, a list of actions and key steps we should follow, knowing which applications have where they have their location, which are, for example, the IP addresses of the service, how we should access them, how we should bring this up, if possible, automation of this process. And of course, we constantly need to update the DR plan because the workloads are changing, the threats are changing, and correspondingly with these, the methods we can use for DR are also changing. Now, again, these are the most crucial aspects of proper DR planning. Now, going straight to the topic, backups. Now, backups from my perspective, from my experience, are not always highly evaluated until the disaster happens or the ransom comes. That's when backups are worth their weight in gold. Now, probably we all know about the 3-2-1 rule, right? So 3 minus 2 minus 1 equals 0. So exactly 0 backup copies you should have. But not seriously. The 3-to-1 backup rule, it's 3 backup copies, 2 different media types, and 1 of them offsite. Now, there are many variations, and the most popular now is 1 more backup copy that is air-gapped or offline, or the perfect word for that would be immutable. Now, why I'm saying immutable and why I don't really like putting them as a synonyms to the offline or to air-gapped backup copy, because we all know that the dedicated backup server or a NAS that is not connected, for example, to the network, or is used to periodically connect, for example, for weekly full backups, is still not immutable. What immutable means is that you cannot erase or rewrite that data, which is not the case with the air-gapped, unless we are talking about the LTO solutions, but we'll get to that in a moment. So immutable actually means that the backup cannot be erased, overwritten. It can only be used to access and to restore your data. So again, air-gapped does not always mean immutable, but immutable can of course be air-gapped. Now, how do we achieve immutable, or in other words, warm, right? Or write once, read many. Now, the number one option, as it was and it still is the LTO. So the physical tapes, they have what I would say the natural protection, natural immutability. Now, this comes since the LTO 3 generations that have RFID chips inherited in them. which basically put them in the state of worm. Now, LTO tapes are still the king. They provide great capacities, but of course, the maximum reliability comes when you are able to offload them to some kind of the secure and off-site vault. Now, this can be your off-site vault for storing the tapes under the proper conditions, or this can be the vault provider. Of course, with LTO, there comes huge maintenance and management costs. So the other option is actually using the object storage, and here specifically, I'm talking about the public cloud, like AWS, Azure, Wasabi, Backblaze B2, that use the S3 protocol that has the ability to put immutability period, right? Since we have the great option for the objects that are basically single containers, having the metadata and the unique identifiers in them without relying on the outside metadata files, it's quite easy for us to store data as objects with time setting for the immutability. Now, again, the public cloud might not always be the case because in the end of the day, public cloud is still someone else's server, right? Again, this can be the security regulations or policies you have in place within your organization or company that do not allow storing the data on the production system or servers where you do not have full control. So again, basically with public cloud object storage, we rely and we trust the public cloud providers, hoping that they perform their due diligence, right? Which again, we cannot always be sure about. Now, I also have the immutable drives here, which is CDR, DVDs, Blu-rays, or also M disks. I'm not going to talk much about them because these are still most of the consumer grade, right? Storing terabytes or petabytes of data on the CDRs would be quite complex. So that's why the other option for combining, let's say, industry-proven immutability with your security policies and regulations is the object storage that is done on premises. Again, we can have public cloud or we can host our own object storage. Now, the principles are still the same. The AWS did a great job developing the S3 protocol. The same one or its varieties are used in on-premises object storage. Now, the good examples would be Cloudian, IBM, if you want to go with the ready solutions. Also, Dell has their offerings. Or if you have the staff that can deploy or roll out your own object storage, there is open source min.io that can be installed on top of basically any operating system or as a container, usually deployed on top of the Linux servers. Now, the other way of achieving immutability is utilizing the file system capabilities. Now, so we were talking about the object storage, right? But it's not the only level. Objects are not the only level that can provide immutability. So we divide this into the, let's say, vendor-specific immutability. Now, the first one is read-only volume snapshots. Now, the operating principle here is quite simple. You need the file system. For example, ZFS, which is openly available, which can create read-only snapshots, basically immutable snapshots. Now, unlike the object storage that is immutable and protected against any write operations by default, we do understand that this is the secondary options, as you need to, first of all, automate or schedule the snapshots creation. Now, if the backups using the ZFS snapshots are encrypted, you can roll back to the created snapshots. But again, this means some of the data loss. Plus, having the ZFS snapshots stored on the same server as your, for example, main backup server where you store all your backups and create the immutable snapshots, might not always make much sense, because if someone gets access to the system, for example, the root access, the snapshots will still be removed. So the immutable snapshots can be perfectly stored on some remote location. For example, while you have a Linux-based, for example, Ubuntu or CentOS server, ZFS creating immutable snapshots, read-only, and sending them over the network with the ZFS send command to some other connected NAS system or remote server. And the other one is the file locking technique. Now, this one is used in one famous backup solution we probably all know about, which is Vim, right? Vim backup and replication. Here, mainly, I'm talking about the combination of XFS immutability flags option and the use of Vim backup and software. Right. In this case, what it does, it utilizes smartly the ability to set the immutable flags on the XFS file system, which would store your backups, and integrated it within the backup software that does not use root access, does not use any other account, doesn't use the SSH connection, and does not store any data about the user profile that was used to create the immutable storage in the Vim database. Basically, I'm talking about Vim hardened Linux repository. Again, for example, a simple use case, you build the backup server, Ubuntu, and you use the XFS file system with the immutability flag, plus Vim backup software, and you add the Linux hardened repository. Basically what this means, even if the ransomware or a hacker gets access to the backup server, they will not be able to remove the backups. Also, they won't be able to utilize the user dedicated one created to add the hardened repository, because it's not stored in the database. And it's also removed from the sudo privileges file once the backup configuration is done. Now, why I'm talking also about this and why I'm separating disaster recovery and backups is because disaster recovery is focused on the time it takes to recover your data. Backups are focused on keeping your data in any case. Now, this comes to the perception when DR means fast, backups mean slow. But it's not always the case. For example, in Starwind, our company, what we are doing, we are building the all NVMe backup appliances that have the ZFS snapshots integrated and also have the integration of the Vim hardened repository. Now, what this can give us is basically to combine the DR and backups in a single appliance, in a single server. Because we quite often understand that keeping the separate disaster recovery cluster or a separate server where you would migrate your applications and having the separate 3-to-1 backup solution is not always feasible. Now, that can be easily the case when you still need fast RTO and RPO by being able to use the all-NVMe backup storage to perform backups every 5 minutes and be able to restore within seconds, plus having the vendor-specific immutability. Now, of course, backups are not the only method when we're talking about the DR, just one of the cases. Now, the other one is disaster recovery as a service. And why I'm talking about disaster recovery as a service? Because not always we have the competence or knowledge to build the proper DR system, to calculate all the risks, to build the second proper DR cluster that would be able to handle the workload, fail over to it, then perform the failback process. Now, in that case, disaster recovery as a service comes very handy. And namely here, I'm talking about the managed disaster recovery as a service, where you basically contact with the provider of such services and you put them on the responsibility for building the DR plan for you, aligning on the RTO and RPO requirements.
question. Is it time for a question now? Could I pose a question?
Almost. Yeah, maybe it will be answered. Right.
Just to tag, можете написати слайд.
Yeah, so there are a lot of companies that deliver such services, like Druva, Commvault, and others, Azure, AWS, VMware. And the other type of disaster recovery is the virtualized disaster recovery. Probably the most simple one and the easiest one to integrate if we are talking about the virtualized infrastructure, which is almost always the case. So usually our workloads operate on top of the hypervisor system, such as VMware, vSphere, or Microsoft Hyper-V. Now, the hypervisors always have the ability to perform the disaster recovery. In VMware, that's the VMware vSphere replication. In Hyper-V, that's Hyper-V replica. These come embedded and are included in the license of the hypervisors, at least in the default package like that. And these allow you basically to create snapshots of the virtual machines, send them over networks, so we're talking about the asynchronous replication, and perform the recovery when needed. So again, these are simple methods about virtualized disaster recovery, or alternatively, again, there is third-party software that can be integrated, and VM backup and replication has it already in its name, namely for the replication functionality, which does the replication exactly of the virtual machines to the other side, for example, the remote side of the server, and being able to restore the VMs to the specific point in time recovery, or simply talking the snapshot. But again, the key aspect here to understand is that we are talking about the disaster recovery. Now, since we have our second sides usually connected on the same management network or even operated on the separate DR network, these are tied to your production system, to your main production cluster. So specifically, if we are talking about the ransomware, if the ransomware hits main production cluster and you have constantly connected DR side, most likely you'll be out of the game even though you have snapshots replicated over the network. Again, unless we're talking about the immutable snapshots. And just to finalize, to make DR simple, what makes really good DR plan without going into all the hassles, it's understanding the critical assets, because it helps us pick the proper DR method and save budget on this. Understand RPO and RTO, because again, you might not need a solution that delivers you 5 seconds recovery time objective. Then, of course, based on these, we select proper DR methods, for example, fast, immutable backups or hypervisor-based replication. And of course, the main thing here is to conduct training, because without it, without understanding what to do in the critical situation, you'll be just losing money in the end of the day. Thank you.